And now we can move on to question 6. How many valence electrons does the phosphorus atom have? Its group number is 5A and atomic number is 15. So we know that phosphorus has atomic number equal to 15. So this means that there are 15 protons in phosphorus. And therefore, if we had a neutral phosphorus atom, then we also have 15 electrons. And this is so that the negative charge can cancel out the positive charge from the 15 protons to give us a neutral atom. Okay, so now let's draw the electron diagram and show the 15 electrons for a phosphorus atom. So the first two would be in the inner shell, so the 1s orbital. And then the next shell can house 8 electrons. So let me draw them in. Okay, so if we count out all these electrons, I've only drawn 10 out of the 15. So we need to have another shell. And we can draw 5 more electrons. Okay, so this is a phosphorus atom. And therefore, we have 5 valence electrons. So the valence electrons, these are the electrons that are found in the outermost shell. And in the case of phosphorus, it is these 5 right here. The junior tutor said that valence electrons are the electrons that can be found in the outermost shell of an atom and occupy the highest principal energy level of an atom. To determine the number of valence electrons, see this table for reference. So they kind of summarized the different trends you see depending on what group you're in the periodic table. So for example, group 1, alkali metals, have 1 valence electron. Group 2 has 2 valence electrons. And groups 3 to 12, which are the transition metals, it kind of varies. So they have a note here that says the general method for counting valence electrons is generally not useful for transition metals. Instead, the modified d electron count method is used. For group 13, they have 3 valence electrons. Group 14 has 4, 15 has 5. So this is where our phosphorus atom lies. Group 16 has 6 valence electrons. Group 17 has 7. And noble gas has 8, with the exception of helium, which only has 2. Phosphorus is in the group 5A. Therefore, it has 5 valence electrons. Okay, so this solution is correct.